We're going to do some problem solving with normal distributions and a bit of binomial. We'll sneak in there too. Okay, so we're going to go by example here, alright, and I'll elaborate on problem solving strategies and any insights you may possibly find interesting. Okay, so here's the question, here's the task. The amount of instant porridge oats, how exciting, it's in packets packed by a particular machine, is normally distributed with a mean of mu grams and a standard deviation of 6 grams. Alright, so that's a bit elusive, mu, okay, not determined at this stage. Anyway, we'll keep going. Just got to remember to address that at some stage. The advertised weight of a packet is 500 grams. So on the side of the box it says 500 grams net. Okay, so there we go. See, there it is. There's a photograph of it. So we've got three things to do. Calculate the proportion of packets that will be underweight, i.e. less than 500 grams, when mu is determined to be 505 grams. Okay, we'll look at part B and C in a moment. Let's do part A. Now, like I've mentioned in passing on other videos, we can approximate things that are discrete in nature, like numbers of packets, okay, which is discrete. We can approximate that with a continuous function, which we're doing here, and in fact if it involves a large enough number of these things, it can be normal distribution, and that's what the name of the game here is in this problem. We're approximating normal distribution, okay, of discrete things with a continuous normal distribution. So with all that in mind, we can, if we like, we can visualize this, and we can put in our mean of 505 and a quantile here. We're looking at finding this area. Okay, the proportion of packets will be correspond with the area under the curve in that region there, which, okay, really enjoy my messy shading of things. It's really good fun, and maybe it'll upset a few people. That's it's beautiful. So we are looking at yeah, when we're looking at less than 500 grams. So what is that percentage there? And it's a tech active question, so we're going to use our normal CDF on our graphics calculator. So putting in from negative infinity through to 500 with a mean of 505 and a standard deviation of 6, we get 0.202328. So let's say 2023. Okay. Okay, and we used a normal distribution with the mean at 500 and standard deviation, which was 6. Okay, so 6 and 505 normal distribution. Part B, we've got to calculate the average or the expected value mu required to ensure that only 1% of packets are underweight. Okay, so we need to find what the average should be to ensure that 1% of packets is underweight. So the average is very informative for the manufacturer. So if we are aiming for 1%, okay, only 1% underweight, what do we do? Okay, so we're trying to find mu, so all we can do is put that in there as such, and 1%, which is 0.01 area. Okay, so that little area there in the back tail, the left hand tail there. Okay, so we're still looking at binomial distribution, a normal distribution, normal, okay, and well, what does it have to be set at? We also know a formula that we can use as well, which may assist us. The definition of a z-score. But first of all, at this stage, we're looking at this, And normally we'd be able to just use a graphics calculator to work that out, because we want an underweight means less than 500, because if we go back up to the question, this is the problem solving aspect. You see the advertised weight is 500 grams, so if it's less than that, it's underweight. Wow. So we'd normally be able to put that in, but we don't know what the mean is, and that's in fact what we've got to find. But we could look at this, the z-score, as I said, and we could use that formula once we work out what the z is here. Now, this z works on, of course, a standardized system where mu is 0 and sigma is 1, so they're known for that. Okay, it's in a standard system. We go to our graphics calculator and we go again, and we got statistics, we got distributions, we've got our normal CDF, and we've got from negative infinity right through to the z-score. Sorry, inverse normal. Try again to get the z-score for an area of 0.01, and that is negative 2.326. So that value we can transcribe over here, and out of these things on the right hand side, we actually know x, there it is, and we know sigma from the question. If we go back up here, it is 6. Okay, now be careful. On the denominator there is sigma, the denominator there is 6, and we can rearrange, and let me do that. 513.96 I get. To 2 decimal places, grams. Okay, the last part. Part C. Now this is actually where the binomial part comes in. This takes a little bit of insight. To check the setting of the machine, a random sample of 5 boxes is chosen. Okay, and they do a little trial here. Okay, a little binomial trial. In fact, the setting is changed if more than one of them is underweight. Alright, so 5 boxes in the trial. They change the machine's setting if more than one of them is underweight. So you've got to calculate the probability that the setting on the machine is changed when mu is 505. Need a different variable, so let u, I'm going to say let u be the number of underweight packs. Okay, underweight packages. Alright, so we have a binomial situation, and we have u, maybe I should write u binomial. Now remember, the two parameters for binomial are the number of trials and the probability of success, so n and little p. So we have u binomial 5, and back here the probability of success when in fact we had the same average that was worked out in part A. Alright, because underweight less than 500, so we've actually got that, and we got 0.2023 last time, so we can put that in here. Alright, see, that takes a little bit of insight, doesn't it? All of that I've done so far in part C. Okay, so that means basically we have the probability for a binomial situation. We have a probability that u, remember it said more than one underweight, more than one underweight, like so, and then we can go to our graphics calculator. Now you could use the complement. You could go 1, take the probability that u is less than or equal to 1, but you don't have to on a graphics calculator if it's tech active. You can actually just go straight in. So let's go straight in, and we've got statistics, we've got distributions. Okay, we've got a binomial. Whoops, wrong. We could use a binomial CDF. We have 5 trials. We have probability of success point. I hope I remember this right. 2023, was it not? Okay, so more than one. So this is discrete. Alright, this is discrete. So 2 through to the maximum value, and this particular distribution is 5. Okay, so there we go. Oh, I've just spotted a very small but significant issue there with the things I've entered in. 2032 versus 2023. Okay, I'm going to try that again. So, alright, so it was greater than 1, so that's from in a discrete distribution. In this case, 2 through to 5. Okay, there we go. That's better. That matches. I did it the other way, you see, and that's why I discovered a little error in what I did. So yeah, it's good to check your answer. So 0.2674 or 2675, depending on your rounding. 0.2674 or 5, depending on how you rounded it. There we go. There's problem solved.